Envision awakening one day, and it isn't hard to find that the world is not a pivoting circle, but rather something altogether unique, something that opposes, in addition to your creative mind. Yet, hundreds of years of logical figuring out, that is what the James Webb Space Telescope has done for our cognition of the universe. Plan to abandon all that you thought you had some awareness of the universe as we dive into the pivotal revelations that are making researchers question their most central speculations. Your idea of the universe is about to be irreversibly changed. Are you prepared? In the long records of human history, there have been a modest bunch of amazing revelations that have in a real sense reclassified how we might interpret the universe. Copernicus moved the Earth from the focal point of the universe. Einstein supplanted Newton's all-encompassing law of attractive energy with his hypothesis of general relativity. And presently, cue the sensational drumroll, the James Webb Space Telescope is turning out to be another Copernican second, another Einsteinian discovery. Before we bounce into the stunning discoveries, we should pause for a minute to appreciate this wonder of engineering and innovation. The James Webb Space Telescope, as it's warmly called, didn't simply come about coincidentally. It's the consequence of long periods of intense exploration, mind-boggling arithmetic, and worldwide cooperation between NASA, the European Space Agency, and the Canadian Space Agency. The telescope is a complex, expressive dance of mirrors and sensors that function together in the cold void of space to present to us the most detailed pictures of the universe that human eyes have at any point seen. So, what's the main sensation that this galactic dynamo has dropped first? Since the concept of a universe conceived from the Big Bang has recently acquired a head-turning preamble, the JWST has uncovered notable proof supporting the inflationary model, a hypothesis setting that before the Big Bang, the universe encountered a practically incomprehensible burst of development. Envision this: the universe multiplied in size once, as well as at least multiple times, all inside a period so small it causes a squint to appear everlasting. This cycle, often referred to as cosmic inflation, suggests that the universe swelled faster than the speed of light. Concerning the mechanism behind this gigantic expansion, researchers are taking into account fields of colorful energy and, indeed, even quantum changes as potential impetuses. So, does the Big Bang now turn into a simple commentary in a much more unpredictable, inestimable account? Could this situation account for the amazing idea of multiverses, each birthed from its own unique inflationary event? What could be the role of dark energy or even quantum mechanics in this? The doorway to noting, or if nothing else considering, these giant inquiries has been flung wide open, in a move that adds much more layers of intricacy to our astronomical understanding. The telescope has made another amazing discovery. 6 massive galaxies, appropriately initiated as galaxy breakers. The name isn't exaggerated. It's an emotional yet exact descriptor. These divine behemoths are breaking well-established suspicions about the timetable and components of cosmic arrangement. They're so distant that the light we're seeing from them started only a couple 100 million years after the indicated enormous detonation, a time when, according to laid-out models, galaxies ought to be undeveloped, not gigantic. Generally, our scientific stories have painted a slow, gradualistic image of galaxy development, one in which small bunches of matter slowly incline toward one another over billions of years to at last form the monstrous structures we see today. The presence of these galaxy breakers messes up that account. Could it be that our old-fashioned models of galaxy formation are overly oversimplified? Imagine a scenario where these behemoth galaxies were results of conditions we've not yet figured into our situations. For example, differing densities of dark matter or even associations with other obscure types of energy and matter. Could their size and intricacy propose a previously impossible complexity in the organization of galactic components? An intricate movement of astrophysical peculiarities that we're just now starting to perceive. Seeing ancient galaxies in their infancy and re-examining cosmic development timetables, this is where things get significantly more interesting. If galaxy breakers and pre-Big Bang extensions weren't outlook-changing enough, we should dive into another staggering aspect of the telescope's revelations. When we look at these faraway galaxies through the James Webb Space Telescope, we're essentially looking billions of years into the past. We're looking at a younger universe, a simple baby in cosmic time, at the point when things should have been just 2% as old as they are now. But here comes the humdinger. These aren't baby galaxies we're seeing. They're mature, created, and as complex as our own Milky Way. This contradicts past cosmological hypotheses, which proposed that early galaxies should have been tumultuous and unstructured. So, what's going on here? Are there mechanisms having an effect on everything that accelerated the pace of cosmic improvement during the universe's early years? One charming possibility is that there could be types of inestimable manure, yet unidentified, that accelerated the development of these youthful galaxies. Another hypothesis spins around the dispersion and dynamics of dark matter in the early universe, which might have played a fundamental role in shaping galaxies at a faster rate than previously thought. And here's another tempting question. If these galaxies matured so rapidly, what does that infer about the life patterns of their stars and the development of planetary systems within those galaxies? Could this accelerated growth also lead to the quicker development of conditions helpful for life? It's like we've accidentally discovered a galactic curve in the plot of universal history, one that may very well rethink the narrative of our own universe's advancement. Also, to highlight how amazing this specific discovery is, let's return to the time-traveling perspective of looking at these far-distant celestial entities. The James Webb Space Telescope gives us the unmatched capacity to be enormous archaeologists, uncovering secrets about the early universe by looking into what is essentially a window to the past. What we're seeing through this temporal lens are extraordinary galaxies, yet ones that appear as created and intricate as the Milky Way, despite existing when the universe was only 2% of its current age. To say that this finding overturns our past understanding would be an understatement of cosmic proportions. So, how did these galaxies grow up so quickly? What cosmic recipe allowed such an assisted maturation? One chance is the role of seed black holes, which are black holes formed early in the universe's history. These could act as gravitational anchors, attracting matter more effectively and thus accelerating the universe-building process. On the other hand, we could check the role of what's known as the cosmic web, the complicated network of fibers made of both ordinary and dark matter that perplexes the universe. Could these structures act as fast tracks for material to come together in the early universe? And we should not disregard the components that make up these galaxies. Were there specific surpluses of heavier elements that acted as a catalyst for faster development? Or maybe these mature galaxies are where we could find the first signs of something else, a new type of matter or energy that we haven't yet encountered, which could be the key to their accelerated maturation. This brings us to another intriguing suggestion. What does all of this mean for our Milky Way? If galaxies can mature so quickly in the early universe, might that offer new insights into the Milky Way's own formative history? Might we one day find celestial kin out there, galaxies that developed rapidly and could have similar properties to our own? The discoveries from the JWST are not just changing the cosmic rulebook. They're inviting us to question the very structure of our infinite ancestry. Right when you thought we were finished attaching how you might interpret the universe, the James Webb Space Telescope has one more stunt at its disposal. This time, we're diving into the hypnotizing domain of star development, with an emphasis on NGC 346, a productive star-forming region. This part of space isn't just charming. It's dumbfounding. Weighed down with dust clouds that are far from scanty, NGC 346 defies us with a cosmic riddle. You see, the standard way of thinking holds that dust clouds act like galactic cynics to star formation, becoming hindrances or even roadblocks on the heavenly highway of stellar creation. But NGC 346 throws this thought into an infinite tailspin. Here, dust clouds aren't smothering the birth of stars. They're facilitating it. So, what kind of enormous speculation are we seeing here? One potential explanation might lie in the complex physics of dust clouds themselves. Perhaps these dust particles are not just passive actors, but rather actively participate in chemical processes that enable the buildup of gas into protostars. Or maybe the dust clouds are particularly rich in specific elements or compounds that act as catalysts for star formation. We also can't rule out the exchange of magnetic fields, which could guide particles and gases into special formations favorable for birthing stars. And speaking of stars, what sort of stars are we talking about here? Are these the familiar solar-type stars we know? Or are we witnessing the development of exotic, previously unknown types of stars that behave differently and have different life cycles? Could these be the nurseries for the most massive stars known to man? Or, on the other end of the spectrum, could they be minuscule, weak stars that defy our current classifications? The discoveries from NGC 346 force us to reconsider not just our hypotheses of star formation, but also the roles that dust and other seemingly inert parts of space play in the mechanics of the universe. Are we on the brink of a revolutionary new understanding of how stars, and by extension galaxies and even life itself, come into being? This isn't just a change to a current theory. It's the birth of a seismic shift in our conceptualization of cosmic beginnings. The Webb telescope pulls the enormous mat from under us again, this time telling us to throw our old calculators aside and prepare for some stunning mathematics. We're not talking about a minor revision or a slight change here. We're talking about a complete disruption in how we might interpret the cosmic senses. According to the data, the known mass of stars in the universe at this extremely enormous moment could be a stunning multiple times greater than what we had previously estimated. Yes, you heard it right, multiple times. Now, let's stop and put this into context. We've all heard the poetic idea that there are more stars in the sky than grains of sand on the Earth. But what if the actual number of stars is closer to being greater than all the grains of sand on every beach and desert on the planet combined? And then some. What does that mean for how we interpret the universe? More critically, what does it mean for how we interpret star development itself? If these numbers prove accurate, the implications are staggering. Early star formation mechanisms must have been operating at levels of productivity that border on the impossible. It's like discovering that your humble engine can not only run a neighborhood quiet, but is also capable of interstellar travel. So, what's behind this turbocharged star creation engine? Could dark matter be playing a more critical role than we originally thought, acting as a secret hand that catalyzes the development of stars? Or are there entirely new phenomena still unidentified that serve as the cosmic kindling, igniting this expansion of celestial dynamics? There could also be something even more perplexing at play. What if these stars aren't the result of accelerated versions of conventional star formation processes we're familiar with, but are the products of entirely new, until now unknown techniques? Could there be alternative pathways to stellar existence? Different recipes for cooking up stars that we're not yet aware of? It opens up a maelstrom of possibilities, each more captivating than the last. This discovery could mean that galaxies, even those formed in the early universe, are far more crowded places than we ever imagined. It raises questions about the types of conditions these stars are forming in and challenges our ideas about how much space is needed for star development. It even opens the door to new types of celestial structures and networks, the likes of which we've never considered. In short, this finding reconfigures not just our galactic models, but also our very sense of cosmic wonder. Are we standing on the brink of a new renaissance in our understanding of the universe? Is it time to change the textbooks and remap our conceptual universe? It's a thought as stunning as the infinite ocean of stars the Webb telescope is revealing before our eyes. After this whirlwind tour of discoveries, one truth remains as distinct as a beacon in the dark sea of our ignorance. Our current standard model of cosmology, the revered framework that we considered our best guess of well-known fact, is shaking on its fundamental points of support. The building blocks of our galactic understanding, once thought to be as steady as the laws of physics themselves, are showing signs of cracks. This isn't just a chip in the shield. It's more like finding that the whole fortress may be built on shifting sands. You may be asking yourself, if so much of what we assumed we knew is being questioned, what, then, can we truly understand about the universe?